How do we guarantee a plug fits into every outlet smoothly every single time? We are Group 9 and our names are Felipe, Jaren, and Michelle, and for our project, we chose to examine a wall outlet face and an electrical plug. Our mating parts include the electrical plug, which has 3 conductive prongs which extend from the rigid housing, and this consists of the 2 flat prongs, live and neutral, and the 3rd round ground pin. The wall outlet face is a fixed socket with matching rectangular and rounded slots that connects with the plug prongs.
Electrical plugs are manufactured to fit uniformly into outlets across the country. Therefore, quality control is required to guarantee that the prongs of the plug meet GD&T tolerancing during production. This standard is also applied to the wall outlet because if the openings do not match tolerancing criteria, the plug will not properly connect with the outlet, which can create a safety hazard. When inserting an electrical plug into the wall outlet, there is nothing restricting the initial motion. However, as the plug approaches the outlet face, there is a small amount of pressure that is required to help align the prongs with the outlet slot. Once the prongs are aligned, the prongs will slide into the outlet with minimal resistance to ensure that there is a secure connection. When removing the plug, a slight pulling force is required to fully overcome the retention friction, and this ensures that while the plug is connected to the outlet, that it doesn't come loose unintentionally. In this drawing, 3 primary datums establish a geometric control framework for the outlet features. Datum A is the back face of the outlet, acting as a primary reference surface for machining and establishing the orientation of the entire part. Each outlet has a nominal width of 2.29 millimeters, as shown in detail B and C. The spacing between the vertical slots is defined by the basic dimension of 10.16 millimeters from the left edge and 12.83 millimeters overall between slot center lines. Datum B is the left side surface controlling horizontal orientation, and datum C is the bottom surface controlling vertical orientation. The location of each slot is controlled by a 0.25 millimeter positional tolerance at MMC relative to datums A, B, and C, ensuring proper alignment of the plug interface.
The plug itself also requires precise geometric control. Each prong has a width of 6.26 plus or minus 0.1 millimeters and a thickness of 1.42 plus or minus 0.1 millimeters. The spacing between the prongs is 11.06 millimeters and is held to a 0.1 millimeter tolerance. These dimensions ensure that each prong slides smoothly into the outlet while still creating the necessary friction for electrical reliability. The front surface of the plug acts as datum A for the plug drawing, establishing the perpendicularity requirement for the prongs. Additionally, the spacing between the prongs must match the corresponding datum B centerline of the outlet. Any deviation beyond the allowable tolerance may cause insertion difficulty or poor contact inside the outlet. Lastly, prong length is controlled to 17.26 plus or minus half a millimeter from the plug datum C to ensure proper electrical engagement inside the outlet. We hope that our video has given you useful insights on how to apply the concepts and tools of GD&T. Thank you so much for watching.